In the last lecture, we spent time talking about the mean or expectation and its properties, most important one being linearity. But let's step back now and think about what is it that the mean means? Why do we care about it? We have this intuitive idea that if you do things long enough, then I know that the expected number, since all the values from 0 through 101 are possible, and the middle value is the expectation, it's 50.5 heads. Now, I'm never going to get exactly 50.5 heads. The probability in 101 flips of getting 50.5 heads is 0, because there's no way to flip half a head. So you don't expect the expectation in that sense. No given measurement, no given experiment is going to yield the expectation. The expectation is this thing that we expect to come out on the average. Well, we can ask, what's the probability of getting as close as you could hope to get to the expectation? Namely, what's the probability of getting exactly 50 heads? And it's about 1/13. Or if you ask, what's the probability of getting either 50 or 51 heads, but being within plus or minus 1 of the expectation, it's about 1/7. Okay, let's flip more coins and see what happens. This time I'm going to flip 1,001 coins. And again, the expected number of heads is 500.5, which I'll never get exactly. The probability of getting exactly 500 heads is 1/39th, and the probability of getting within 1 of the expectation, that is either 500 or 501 heads, is about 1/19th. Now, these numbers have gone down. From the previous numbers, remember, it was about 1/7th, and we've gone down to 1/19th. So it's actually, we're less likely to be within a fixed distance, within 1 of the expectation when we flip more coins. So as the number of tosses grows, the number of heads gets less likely to be within any given fixed distance of the mean. But things get better when we start looking at percentages. So what's the probability of being within 1% of the mean if I toss 1,001 coins? Well, 1% of 1,001 is about 10. So we're talking about 1% of 1,001. And the probability of being within 10 of 505, that is to say, the probability of being within 510 and 490, is about 0.49. It's almost 50-50. Which is not really so bad. So we have a 50-50 chance of actually being within 1% of the expected number when I flip 1,001 coins. So what we can start to say is that when we're trying to give the meaning to the mean, if I let mu be the standard abbreviation for expectation of r, I'm doing that just so it'll fit on the slide nicely in formulas, so mu is the expectation of r. The basic question we're asking is two basic questions. One is, what's the probability that the random variable is far from its mean, mu? And you could phrase that as, what's the probability that the distance from r to mu, the absolute value of r minus mu, is greater than some amount x? And the second question that we want to ask is, what's the average deviation? What's the expectation of the distance between r minus mu? What's the expected value of r minus mu? Now, of course, we're trying to make sense of the meaning of the expectation in terms of the expectation of the distance between r and its expectation. So there's a little bit of circularity there, but let's live with it and proceed. Let's look at an example to crystallize the ideas a little. Let's look at 2 dice with the same mean. The green die is going to be a standard fair die in which each of the numbers 1 through 6 has an equal probability